Morning. Today we are covering 8.3, which is a vertex, form, and transformations. Vertex, form, and transformations. Okay, so let's fill out and talk about what vertex form is. It is the form for a quadratic equation. What that actually looks like is y equals a, open parentheses, x minus h, close parentheses, squared plus k. Now let's talk about what all of these letters represent. The new letters we're used to seeing are the h and k. So the h and the k are the vertex. Notice the h is in the x spot, the k is in the y spot of the vertex. So based on that, that means that my axis of symmetry, which is the AOS, is x equals h. Now, what you've got to pay attention to is this is a minus right here, not a plus. So you have to remember that as we're working. So we are just pulling just the h out, and this has to remain a minus. Okay, so let's look at some problems. Number one, it wants me to pull out the axis of symmetry, which means that's the h. Well, right here, this 4, that's a plus 4. So that means this can be written as x minus negative 4 to become that plus. So that means my h is equal to negative 4. So my axis of symmetry is going to be x equals negative 4. When I'm looking at this is a minus 2, but in the formula, it's a plus k. So that means this is going to be plus negative 2. So therefore, the k equals negative 2. So my vertex is negative 4 comma negative 2. All right, one more. Let's look at number 2. If I'm looking at this, there is no k written. Well, since there is nothing added at the end, it is understood to be plus 0. Okay, this one's kind of easy because it's a minus 3. So I know right away that my h equals 3, and we just found out that my k equals 0. So my axis of symmetry is not h equals, it's x equals 3. The vertex is 3 comma 0. Okay, moving right along. The next section. Now we're going to talk about graphing these, which we're going to use our calculator for. So if you don't have it, pause and get the calculator. Let me move a few things around here so I make sure I'm doing things correctly. Okay. First things first when I'm looking at graphing it. Okay. Axis of symmetry. I can pull that information out here because remember, this is, we'll do brackets here. X, because it's a plus 2, that means it's going to be x minus negative 2. Then that means that my h equals negative 2 and my k equals 7. So the axis of symmetry is x equals negative 2. My vertex is negative 2, 7. So I can go ahead and put that in the middle, and then we've got to find the table of values around it. So that means we go to the calculator and the y equals, because I want points to plot. I'll put this over here. I type in that equation, which is y equals negative. So that's not the minus, that's the negative button. Open parentheses, x plus 2, close parentheses, squared plus 7. Excuse me, go to the table of values, and I want to find my vertex first off and go 2 above. So now I see my points are negative 4, 3, negative 3, 6, negative 2, 7, negative 1, 6, 0, 3. Okay, now we plot our points. Oh, before I do that, I'm going to look at what the graph is. So I'm going to go to graph. And what I notice right now is it opens down. So let's talk about domain and range again. Remember that domain refers to, okay, so domain is all possible X values. Range is all possible Y values. So domain is X, range is Y. Oh, and I want to add a note up here talking about the double negatives. So we've got to watch for double negatives. Okay, back down here. So I'm looking at my graph on the calculator. I notice everything. My domain, it's not going to stop going out this way. It's not going to stop going out this way. So I have no limits on my domain. So we write all real numbers. Now, for my range, for about how high or how low it can go, well, it's not going to go any higher than this right here, which the highest point is my vertex, which means I can look at my K to help with determining the range. The highest it can go is a +7. So but it can be everything below that. So my range is Y is less than or equal to 7. And now we graph it. All right, so I'll plot my points. So I have 0, 3, -1, 6, -2, 7. And then you'll notice you can just plot one away for this, and it's going to be even. Now, I want to continue because that's only on the top half. I want my graph to show all the way through. So I'm going to go back to my table and I'm going to find one more out this way. So I've got -5, -2, which is going to also be 1, -2. And then after that, it's too far. So now I can sketch. And we sketch here. And there's my graph. And we've done all possible parts for this problem. Okay, now we're going to talk about transformations. Next page. So we're going to define some things first, like normal, so we can understand what's going on. So here we go. So the most simplest quadratic, so simplest is y equals x squared, and then everything changes from that. So this is known as the parent function. Okay, so transformations are always from the parent function. So it's how does it change from here? A transformation is a change to the size or position of a figure. So let's look at a couple of them. When we do this in the calculator, okay, because you're going to get your information from the calculator. In the y equals, we're going to clear what we have there. We're going to always make our first one y equals x squared, because that's always what we're comparing to. So we're going to say y1 equals x squared. y2 equals the problem. Okay, so now we punch in, we go arrow down to where we can now punch it in. So we have open parentheses x plus 2 close parentheses squared. And now we want to graph this. So if you want to, you can hit zoom 6, so it's the standard window, so you know it's not off kilter at all. All right, so that's the parent function. That's the original form. Now we're seeing, well, how did this shift? The red one looks like it stayed the same size, but it just moved to the left. So that's what we write. The transformation is that it moved to the left. Well, then what we're going to do is we're going to see, you might be able to see on the graph how much. 1, 2. So we would say the transformation is left. If I could spell, it would be nice. Left 2. Now let's graph it actually and confirm that, okay? So we have y equals, go to the table of values now, and we're looking at the red graph so that I can find stuff to plot. Well, I can pull out the vertex without looking at the table of values actually, because this is understood to be +0. This is my h, and this is my k, that's a plus, so the h is actually going to be -2. So I'm going to have -2, 0. And then I'm looking around there. So I've got -2, 0. So this is going to be 4, 1. Nope. Kimberly, stop. This is 4, 1. And this is 1, 4. This, the x values are -3, -4, -1, 0. Here we go. Now we can plot the points. The vertex is at -2, 0. I have -3, 1, -4. I'm going the wrong way. That's -1, 1. And then I have 0, 4 here. 1 and then -4. And now we play connect the dots and make the U shape. It is not a V. It is a U. You put the arrows on the end and we can see, yes, we shifted 1, 2 to the left. 2 to the left. So my description is, it is to the left 2. We can also look at our equation and we say left 2 because h equals -2. So to the left, now we'll write this over here. Left equals negative. So now let's keep, which means that the right is going to equal positive. Well, based on this as well, if I'm thinking about this, up is going to be a positive. No, Kimberly. This is what you get for Russian. You write things wrong. Here we go. So down is going to be a negative. Up is going to be a positive. Okay. Don't need this over here anymore. All right, let's work another one now. We're going to jump down and do one that's got more parts to it now. Okay, so we're going to look at number 10. All right, so if I'm plugging in, I'm going to the y equals. First things first, I'm going to pull what I can from the equation itself that we've learned. Well, right now, I know that my a, which is the number in front of the parentheses, so I know a equals -1. I know that h equals 4, and I know that k equals 1. So I know I've got 4, 1 here because my vertex is 4, 1. So I know that this is a -1. That means, that tells me since the a is negative, it's going to open down. Okay, well, we're going to confirm that in notes in just a minute. So now we need to think about what's the graph going to do. So let's see, plug this into the calculator now. So I go to y2, clear it, and I'm plugging in negative, open parentheses, x minus 4, close parentheses, squared plus 1 graph. There's my parent function. There's my, whoa, it turned upside down. So it reflected, shifted to the right, and it looks like it also went up. Okay, so let's graph this on our graph so we can find specifics. Okay, so now we go to the table of values. And I'm finding my vertex, which is 4, 1. Okay, and then I need the 5, 0, 6. Oh, I'm going the wrong way because these are positives. I need to go the other way. I have 2, 3, 4, 5, 6. 3 is 0. 2 is -3. 5 is 0. 6 is -3. And now we plot those. So we have 4, 1. I can see right now that's shifted over 1, 2, 3, 4 to the right, and then went up 1. So I can write that right 4 up 1. That's what my vertex did. Now we plot the points. So I have 2 is -3. 3 is 0. 5 is 0. And 6 is -3. And then 1 is -8, which is going to be here. And that means 7 is going to be here. So now I can draw my graph, make my parabola. So I have it's right 4, up 1, and it also reflected or flipped over x-axis. Okay, next problem. I know this is kind of a lengthy little video, but it's transformations can be confusing. So let's talk about one more of this section. I'm trying to speed up because we've already done some things, but not speed up too much. Okay. All right, so from here, we're just going to take and plug this into the calculator because it's not looking like it's in direct vertex form. So I'm going to plug it in. It doesn't look like vertex form. It kind of looks like standard form. So I'm going to go straight to the y equals, change the second one, clear. I'm going to have 3x squared minus 7. Enter. Now I'm going to look at the graph. And I'm going to look to see what happened. There's the parent function. And now what did it do? Oh, so it's shifted down, but it also looks like it's skinnier, narrow. Okay, so we could say this is narrow. It's narrow, and it moved down. How many? I'm not sure, but I did move down. So let's go to the table of values. Now I'm looking for the vertex. I'm not sure from my equation, so I've got to look to see where do these values start to repeat. Oh, if I look right here, that point 0, -7 is where these y values start to repeat. See, it goes -4, 5, -4, 5. Okay, here we go. 0, -7, 2, 4, 6, 7. And then we have -1, -4, -2, 5, 1, -4, 2, 5. And we plot them. Oops. -1, -4. And here's the one on the other side. And then there's -2, 5. 4, 5. Okay, and now we sketch. Well, if need be, I can count it moved down 1, 2, 3, 4, 5, 6, 7. So it's down 7. There's my description of my graph. Okay, jumping to this next section down here at the bottom. Okay, this is where we're going to put it all together and be able to talk about how you can pull it from the equation exactly. Okay, H is the horizontal shift. So that means this is where if it's a positive shift, it's going to be to the left. If it's a negative, it's to the right. H is the horizontal shift. I think that's supposed to be flip-flopped because if it's a negative number, it's going to go to the, I don't like the way they write that. So, because if it's just saying if H right here is positive, this is written incorrectly. The positive goes to the right. The negative goes to the left. So if H, that's the absolute, that's just H. The number that you pull out, what H equals is positive, then you have the right. If it's negative, it goes you to the left. The K, that is your vertical shift. So if it's positive, you go up. If it's negative, you go down. Now, if A is negative, the function is reflected across the x-axis. Now, this is where we get into if we're going to change these words narrower to an actual mathematical terminology. If the A is greater than 1, okay, if the A is greater than 1, then it is considered a vertical stretch. If the A, the absolute value is between 0 and 1, that means it is a fraction or decimal, then the A represents a vertical compression. Okay, so up here, the A was bigger than 1. It's a 3. Notice it got narrower. That means that it vertically stretched up. So therefore, as the parabola was pulled up, it got narrower because it was stretched vertically. When it's a compression, that means it's going to be pushed down. So therefore, the parabola is going to get wider. So the compression, so stretch is narrower, compression is wider. All right, let's look at a couple of these. Okay, if I'm looking at this, it says, we're going to jump down with it. Let's look at 16. It says it's translated 7 units to the right. So that means H equals 7 and 4 units up. So that means K equals 4. So my equation is going to be Y equals open parentheses X minus 7 close parentheses squared plus 4. That one wasn't really very difficult. Okay, let's look at 14. It says just 5 units up. That means only the K is changing, and that's a positive. So therefore, I'm taking the parent function, which is Y equals X squared, and I'm only adding the change for the K. So that's going to be just plus 5. This is my final equation. Notice I did not put in the H into the vertex form. You just doing how does it change to the parent function? How changes to parent function. Okay, all right. let's look at one more example. Okay, let's look at 20. It says vertically stretched by a factor of 2. It's reflected, and then it's 4 units left. Okay, so this means that my A is going to equal 2, because that's when up here it's talking about the A, so therefore it's my A is 2, but it's reflected, so therefore it's a -2. It's going to the left, so that means I'm talking about H, 4 units to the left, so that means it's a -4. So now we plug into the vertex form. So I'm going to have y equals -2, open parentheses, x, to minus -4 squared. There's no movement up or down, so I don't need to write the k, but I must simplify this. So my actual answer is y equals -2, open parentheses, x plus 2, close parentheses, squared. Again, if you've got questions, make sure that you come and ask. Y'all have a great day.